Right, let's do some more validation. See, in the last episode, we validated the age, or at least we clamped it to a certain range, meaning we didn't have to worry about the error messages that we might have to tell the user if they got the age wrong. Obviously, the best thing you can do with a user is prevent them from doing anything wrong, because if they can, they will. But in the case of name, I wanted them to be able to type anything they like and inform them if they got something wrong. So let's have a look at it in action, and if I go to Ali here, if I try to add a 1, it's going to tell me that the name cannot contain numbers. And you can also see that the OK button there has been disabled until I remove the invalid characters. So let's go down to the implementation of user and see how I've done that. Now this is the 5th episode, so we've done 4 building up to this. And I really recommend watching the previous episodes if you haven't done already, because we are again building on what we've learned, and I'm not going to be explaining everything in detail. And with that being said, let's get on with it. As you can see at the top there, I've got an error message state variable. That contains the string describing the problem, the one the user sees. And I'm basing the validity there on whether or not the error message is empty. If it's not empty, there's a problem. And if it's not valid, I'm putting a subheadline text just above the text box. And if we go down even more, we can see that I'm utilizing that onChange modifier once again to validate the user after the text field changes. So if we change the name, the user has changed, it runs validate user, and then in the function validate user, I update the error message with whatever the error message might be for that particular name. If we go down even further than that, we can see that I've got this enum with a static function in it, which is a convenient way of having some validation for a name. We can see I've also got an extension, which checks to see if the name contains any numbers. So all of this stuff is external to the user and is actually controlled by the edit view. We want to put all of that in a property wrapper, not necessarily because it's the best solution to this problem, but because by doing so, it's going to teach us a little bit more about property wrappers and how to implement them. So the elements we've got are validating the name, being able to call validation when the name changes, and being able to set some kind of error message when there is a problem and responding to it. So let's go up to the top again. And as we did before, we're going to label this struct as being a property wrapper. We're going to call it validated, okay? And the type that it contains is going to be equatable. And that's because we don't need a comparable type this time, but we do want it to be equatable so the struct itself can conform to equatable as we did with the clamped property wrapper. So let's put the conformance in now. Equatable. And being the only thing we actually need to be a property wrapper, I like to put in the wrap value first. Var wrapped value, which is T. And this is going to be backed by, again, underscore wrapped value. Private var underscore wrapped value, which is also of type T. This property wrapper is also going to be where we're going to store the error message if there is a problem with the validation. So let's put an error message in. Private var error message. We're going to initially set it to an empty string. We're also going to need a validate function. Private. And because the result of validation is going to be changing the error message, we need to label this function as mutating. Validate. And for now, we'll just say to do. But now we can set up this wrap value computed property. So I'm going to say that the getter just returns the wrap value as we did with the clamped property wrapper. But in the setter, we're going to do something a bit different because we're not going to prevent an invalid value from being set. Wrap value is the new value. But afterwards, we're going to call validate, which means that if the value is invalid, the error message is going to contain the appropriate message. So the validation itself, how do we do that? What we need is a function that takes a T and returns a string, which means we need a property of that type. Let's put that under wrapped value. Private let validation handler, which is going to take a T and return a string. And then we can use that in validate to say that the error message is equal to the validation handler called with underscore wrapped value. So once that's run, the error message will describe any problems. And now that we've got all our properties in place, let's put an initializer on it so we can actually use this property wrapper. Init, remember the wrapped value has to be first, which is a T. We're taking a validation handler, And this is going to be escaping because we're going to be storing it for use later on, of a type that takes a T and returns a string. Underscore wrap value is the wrapped value. The validation handler is going to be the validation handler. And now we call validate, just like we do when we update the wrap value using the setter. So now we know that the error message is going to contain the appropriate value. You may remember that when we wrote the last property wrapper, what we did is we used our own implementation rather than the synthesized version of Equatable because we only want the value to be driving it. We want the same thing in this case. We only want the value of two validated property wrappers to be the same if the values they contain are the same. So let's nick this implementation, duplicate, and then we'll take this one down to our property wrapper. Oh, the wonders of consistent naming, isn't it fantastic? And we're almost done. But if we look at the implementation of clamped, as you'll remember, I didn't implement projected value because I didn't have to implement it and it wouldn't provide any benefit. But when it comes to validated, it would provide a benefit. In fact, it's crucial for the functionality to be able to see the error message. So for projected value in this property wrapper, I'm going to return the error message. So I'm going to say var projected value, that is a string, because it is the error message. And now I should be able to resume, and then we can start using this property wrapper in earnest. And we do that by going up to our user, and in front of our name, we're going to annotate it with validated. And because this takes a validation handler in the initializer, I can pass it in here. Validation handler, and I'm going to pass it the validator that we were using in the original. Validate name, just like that. And then I can initialize it with a value of empty string, which will be used as the wrapped value argument in the initializer. And now we can get rid of the manual validation that we had in our edit view. Let's go down to our edit view and we can get rid of onChange. We can get rid of validate user. We can go up to the top of the edit view, get rid of the error message and get rid of this computed property for is valid. And now we need to make a couple of changes so the validity of this edit screen is depending on the validity of the user itself. Because if I build this, you'll see that there are a couple of problems. And there are more problems down here. So what we're going to do is we're going to go up to our user again and we're going to put in a couple of properties. We're going to say that is valid is a Boolean, and this is going to be dependent on the projected value of name, which remember is the error string, okay? And if that's empty, it's valid. Is empty. We need another property, which is the actual error message. Var error message, which is a string, and that literally returns the error message, which again is the projected value of name. With these in place, we can go back down to our edit view again and start fixing these errors. Instead of is valid, we say user is valid. Instead of error message, we say user error message. And down here, instead of is valid again, we just say user is valid. Now let's resume and see if it builds. So let's go to Anthony, try to put a 1 in there, and look, it's not letting us click OK, and it's telling us that it cannot contain numbers. And in fact, if I get rid of everything, it cannot be empty. It has to contain more than one character. It's all working just as we expect. Over the course of this series, I hope you've learned something about property wrappers. I hope that they're not too confusing for you anymore, and in fact that you want to embrace them to write your own property wrappers that are going to push your code into more Swifty territory. If you did like this series, or if you learned anything, or if you didn't learn anything, and maybe you just enjoyed it and you just came along for the ride, do like the video, it really does help a lot. If you want more of this kind of thing, consider subscribing, because you might be watching this and you're not subscribed, and you might miss the next episode, and whatever it's going to be, I'm sure it's going to be brilliant, so you don't want to miss it, and why not click the bell to reduce that possibility even further. If you have any questions, comments or suggestions, please leave them below, but in the meantime, thanks for joining me, see you next time.